So good day, everyone. My name is CJ Jamuda, like Esther, introduced me. Don't mind the name Internet of Energy is just like the new buzzword. But what Internet of Energy simply means, basically, is just like you're using what they call IIoT devices, so Industrial Internet of Things, to optimize energy processes. Then also, through that you can, eliminate waste. So that's just what it is. But the key thing about this talk, what drove the inspiration for this talk was, in California, roughly like in from 2018 to 2019, we've been plagued by, wildfires, one type of wildfire. So I'm here to talk about, can Python possibly prevent California wildfires? So just join me as I run you through the slides. So just kind of a quick rundown of what I'll be talking about today. First of all, I'll give you an overview of the California electricity grid. Right now we're enjoying, electricity, but we don't really know how, all that came about, right? Then also I'll talk about the most devastating California wildfire. Then additionally, I'll talk about transformer, because transformer fires and explosions, they occur, but you don't get to see that, a lot in the news. Then talk about the general causes of electrical fire. Then obviously go to the more fun part, which most of us are out here for, talking about how we can use Python to be able to, access those embedded systems integrated to those critical grid facilities, and, how we can, run, advanced analytics, and how possibly, Python can, help out. And, round off with like closing remarks. So just a quick feel. So the electricity grid is basically made of like four core components. One is the generation system, the transmission system, the distribution, and what's not so talked about is what they call the electrical substation. Because the electrical substation is almost the part that ensures that your generation system, your transmission system, and your distribution systems, they're all working, right? So I'll talk more about that. The great thing about California is that, we're just so blessed in terms of the amount of energy we have here. So in California, we have what they call solar farms. We have what they call like wind farms as well. We have what they call, hydroelectricity. Then we also have gas plants here in California. So we have all of them. But just to highlight one of the solar here in California, it's called the Desert Sunlight Solar Farm. It's in terms of, what they call installed capacity, is like the second largest solar project in the entire world. So we have it a lot here in California. Then, just kind of, share, a little bit of, one of the wind farms we have here in California. That's, also pretty big in terms of, worldwide, in terms of the capacity and how large it is. It's located in California here too. This is not so far away from us. This is like the Castaic power plant. If any one of us have ever been towards the 5, you might come across this, And there's also what they call like Castaic Lake. I think it's probably maybe like, kind of tied to this, But yeah, around that neighborhood. So this just gives you a feel of, one of the generation plants, a hydroelectric generation plant we have here in California. Then last but not the least, I captured, this is like a gas plant. It's a natural gas plant. It's also in California, all in California. But there's a lot of, generation systems. I just captured, this for one. The pictures look so great, and they're pretty big too as well. So without much further ado, you've generated all this power, right? How are we able to be out here with electricity? How we're able to, heat and cool? You need what they call the transmission system. So the way I look at it more like, from dev standpoint. So you can look at the generation systems almost like your server. Then your transmission system more like your middleware. Then, your client is more like, your distribution system. So this is basically like the middleware that makes sure that, the amount of power you generate, right, you get it to, the distribution side. So this is, you can't really see it so clearly, but what the key message I just want you to capture is, if you look at the legend on the top right-hand corner, you see like the substations. When you look at the different utilities, and you look at the map, you get a sense of feel of, what utilities, in, what area in Los Angeles County actually, maintaining the substations within there. Then in terms of the transmission lines, they have like different, ranges. There's high voltage, medium voltage, low voltage. But if you go to the California Energy Commission site, you see a clearer picture of this. This is not so clear, but yeah, feel free to, dive more deeper into it. Now, you've been able to transmit the power. I mean, beyond the transmission system, you need a distribution system. So just to give you a sense of, most of us, around where we live, we do come across, a distribution transformer, a pole-mounted distribution transformer that finally feeds, power to be it your residences, be it for like, commercial facilities or even industrial facilities. Now that we have a feel of the generation, transmission, and distribution system, the very important piece that makes all this work, be it like in the generation system and the transmission system or distribution system, is what they call the electrical substation. It's not so talked about, but folks like me, we do things in the energy and power industry, so we're very, curious about, how all that fits into place. So this just gives you a snapshot of, the electrical substation, how it looks, and you get to see like in the transmission system area, generation system. But I wouldn't, I wouldn't go through all this, but obviously I'll have the slides available. You can go in, to, look at, all the different, major parts of the electrical substation system. But the key message to pick out here is the main transformer, the one number 9. So transformer is a very critical component, of, this substation system. So you can definitely, go ahead and, check this out later on. Now heading back to the driver behind this talk. It's the Camp Fire that happened in 2018. The figures you can see over here, speaks for itself. It's the deadliest and most destructive wildfire here in California. 85 dead civilians, so many destroyed structures, and so many different things. So that's the main motivation behind this talk. What was the cause of the Camp Fire? So the picture you have on the left is basically what they call a C-hook. So what the C-hook does, it helps you connect the insulations, the insulators that that connect the power lines to the transmission, what they call transmission to power together. So it broke off. As a result of it broken off, and also with high winds that led to different kind of short circuiting and eventually fire, right? So the picture you have on your right is typically, that's how the C-hook should be mounted, with no issues. So that gives you a sense of feel of, what could, something that seems, pretty trivial like that, how it could, spark, that amount of, craziness. However, like I talked about, the transformer is a very important piece of the substation. So transformer fires too, we also, experience, transformer fire. So I just thought, I kind of give you guys a sense of feel of how it typically happens. Just play a little bit quick clip you see. So this actually happened in California late last year. A substation, engulfed in fire. If you look clearly, you can see, some of the picture I shared earlier about the substation. But, these are, what could happen. It could lead to like a lot of, loss of electricity for several homes and several businesses. You can later go YouTube and watch more about it. However, the causes of electric fire is just like, several causes. We just mentioned like, a couple of them. But here in California, high winds and high temperature really, it causes a lot of, it causes a lot of electrical fire. But also me and you, when we go out, be it, hike or for camping, we set up our barbecue and we don't turn it off. We don't turn it off properly. additionally to rodents. So rodents, I mean something like squirrels. It could be from squirrels. It could be from rats. Name it, or grass cutters. In all those areas, it could actually lead to what they call electrical arc and eventually electrical fire. But now, since we already have a sense of feel of the different causes of electrical fire, how do we think Python can help prevent it? So I will introduce to you what they call Micropython. So Micropython pretty much is basically you writing Python code but for embedded devices. The great thing about using Micropython is just that it's so lean, and most importantly is that you can implement standard Python tree libraries on embedded devices or unconstrained environments. So I'll walk you through kind of like the different ways you can, first of all, setting it up and running, MicroPython to be able to access those embedded systems of critical infrastructures in the grid. Obviously, we know, previously, right? I mean, C++ is, it's, although we have Rust, we have several, programming languages you can use for embedded systems, right? But C++ has always been the number one, programming language for you to use for embedded system. But why we all here like Python, or why I like Python, I don't know about you, just that it's quite intuitive, easy. You don't have to do the whole crazy C++ memory management and all whatnot, right? It's easy to use and convenient, and it's the same thing with MicroPython. So literally, you're just transcribing all the skills you have in Python in MicroPython. But some reasons why people use C++ is because it's really fast, right? But for the most cases, right, using MicroPython is really fast, right? And additionally, too, is that in MicroPython, too, you can actually make C++ codes. You can make you can call, C++ file. And also you can use, you can even call assembly languages too, even going lower level from, with MicroPython. So those are, some of, attractive features, and for Pythonistas like me and I guess everyone here, that's why you want to, think about, MicroPython. Some other features too about MicroPython is being able to use, you can actually use so if anyone has ever coded with C++, right, you got to compile it, you got to, just a lot of different things. But with MicroPython, you can actually use the REPL and interactively, run pretty much test your, embedded systems and, test your code, see what how far it can take you. Then in terms of the accuracy you want to achieve, you being able to define certain arbitrary precision integers, you can do that. Then so many other things, closures, list comprehension, generators, and like I said, it imported part of the Python 3 languages. So there are a whole lot of features that you can use from it. Also, it supports numerous types of architecture, the ARM, the x86. Several architectures. But now, we have a sense of feel of, MicroPython. How can we set it up? The key thing about assessing MicroPython is, typically when you, let's say when you deploy your VM, right? You SSH into your instance. So the only way you can SSH into a MicroPython, since you're running embedded devices serially, so calling the command screen dev, the dev, this just, it's basically the address of your device, of your embedded device. Then also, how much bit rate do you want it, to transfer or read data. Then once you've, SSH into your, just like you SSH into your instance, once you've been able to access your MicroPython embedded device, right, you can now be able to, run whatever business complex logic. But in our own case, right, we're talking about how we can help prevent California wildfires. So for us, could be, running, what they call grid situational intelligence, more or less, how can you be able to inform, be it the utility company or operation personnel, to alert them to hey, likelihood of, fire or other, other things happening in the grid. So some of the things when you're running, they're just certain important notes you need to take note of when running your Python code. First of all, if you will be, I mean, more often than not, right? If you have your critical grid infrastructures located in such remote locations or wherever they are, you want to be able to access the internet. So the first thing you want to do, you want to define your network fabrics that's going to be able to connect and transmit the data for you. So in MicroPython, you always have to name this file, what they call the boot.py. It's called, you have to name it boot.py. So it's almost like a startup, script that starts up to, connect your embedded devices to the network. Then once you've, so typically you write the code on, now they have like, good amount of, different IDEs that you can, different plugins you can use for, writing your MicroPython code. But this is mostly if you're running it on the command line prompt. You want to, first of all, write the code. Then you need to upload it to your embedded device. So how you upload it? You upload it with a tool called Ampy. Ampy is a Python API being built by the folks at Adafruit. So what it does for you is helping you like transfer your local files to your actual embedded device. So for this talk, since we're more concerned about the grid infrastructure, I'm more concerned about the transformer system. So we'll be using what they call the BME 280 sensors. So the BME 280 sensors has like what they call, it has the temperature and humidity sensors. So the code you can see, the code I have right here is basically just a code that you actually need to be able to read that data from the embedded devices. To be able to read that data from the embedded devices. But first things first, right, you have to do is that you have to, if you're, doing it like me, you write the scripts locally, you also need to later on upload it to your microcontroller board. And you also have to name it under the file main.py. So just note of the boot.py for the startup, for starting up your embedded system, and also the main.py for actually running your business logic. So now I'm just going to share with you guys this same code, how I ran it locally too, just so you have a sense of feel that it's not just all talk. And hopefully this works. But I tried it earlier, it worked, so fingers crossed it should work now. So like I talked about earlier, first of all, I SSH into, just like this. What?
Did you make the text larger? Is that possible?
Pardon?
Command plus a few times.
Command. Oh, okay. Command plus. Okay, let's see. Oh, sweet. Yep. Sweet. Okay, moment of truth. Okay, what came out? Oh, it didn't come out? Let's see. Okay. Wait. What? Is that working? Oh, shit. Things got screwed up. So do we have more time for this? Yeah. Yeah, I guess so. See there. Okay, so let's see if this goes again. Try one more time. Come on, to disappoint us. Okay, so you can see. So the same code, no difference. So this is telling you, the temperature of the room right now, it's about 67 degrees Fahrenheit, But it's the same code, this same code here. One second. So this same code here, right here, this is just what I ran. There, but already uploaded it to the main.py file, right? But Another thing, great thing, I mean, if we have more time, is that so for when I talked about the REPL, right? The great thing about the REPL is that right now I can interactively go now, you know, I'll just show you right now how I can use, the REPL to do some, I mean, cool stuff.
And the REPL is running on the device.
Exactly. It's running on the device, yeah. It's running on the device. So now I can just copy this code, right? Paste it. So I can, just access, my, variables, So interactively, that's what you can't even get with like, C++. So this are like, some of like one of the reasons why, yeah, I mean, some of the things, I mean, the great things about, Micropython. So now we've seen, a little bit of the demo. I'll have all this available, and you can go ahead on your own, and get it. But once you're able to like access the different sensor data from these embedded devices, you can be able to do so many things. You can be able to, like I alluded earlier, alert the maintenance and the operations personnel there, about a certain, I mean, the health of the grid. You can be able to do, more advanced analytics of even predicting, the likelihood of, fire before it happens. That's, I mean, pretty much, what MicroPython does. Then I mean, just kind of concluding remarks. One thing I understood about, is it possible for Python to prevent, electrical wildfire? It can't just be only Python. There are just like a myriad of different problems, right? One of them is just environmental and human factors. There are some of them, those sensors can be there for you to be able to, tell what it is. But what I know is that, at least it can, guide and support, helping us, having a more resilient grid and a more environmentally friendly grid. I have the references for some of the things I captured here on my talk for you to go ahead and explore more. And that's all from me. Thank you. Sure.
Yeah, so does every substation have one of these embedded devices, or is that something you're trying to add?
They do have one of these embedded devices. Yeah, they do.
What is it called? The embedded device,
Oh, the name. So for this, right, we use, what they call an ESP32. I did have one of it here. I have one of this year. Oh, I think so, yeah. Yeah, I mean, yeah, so I'm talking about that since you're from Oscar Health. So the funny thing is this, right? So, like, what they call the pacemakers, right, for the heart, right? Just same typically kind of the embedded. So you can actually even use MicroPython for like, pacemaker, since we're in Oscar Health. So, so you can even like, yeah.
Yeah, because I used to work in power industry.
Oh, okay.
I mainly work for Synchrophysics.
Oh, okay.
It's all PMU unit.
Oh, okay.
So that's much more expensive, like 10K per snake.
Yeah.
I'm just curious, like, what it is cost, how much it is.
Yeah.
$3 chip.
Yeah.
Oh, $3. It doesn't matter on the pay.
Yeah, yeah, yeah.
$3 for that and $2 for
Yeah,
the sensor, right?
yeah, yeah. Baseball.
Yeah, I was hiking in the Santa Monica Mountains and I noticed that they replaced a bunch of like poles and a bunch of transformers. And I do trail maintenance up there, and that's like really important up there. But it seems to me like an embedded device, it will tell you if the transformer is burning up because the environment will be hotter, right? But it isn't going to stop the fire.
Yeah.
In addition to like this kind of stuff, it seems to me like it would be good to have people going out and checking these things and seeing how old the poles are, how old the ceramics are.
Yeah.
It is something more than just an embedded device. Probably won't tell you the wind because you have to have a spinner. But maybe there is a sensor. Whatever you're limited to whatever sensors you can actually
Exactly.
to the device, and that doesn't take care of everything.
Exactly. And that's why I mentioned, it's just beyond, Python, right? But you mentioned something, if you have like a wind sensor and an thermometer, mounted there, you just connect it to your embedded device and, you can access that, you know. And talking about people monitoring, so what? Okay.
It might increase the like response time to know
Yeah.
that a particular transformer is like burning up.
Mm-hmm.
But that doesn't sort of, that isn't really preventive. That's supposed.
Do you find that you have a correlation like with your humidity data, like locally?
Mhm.
Like, oh, it's more likely that this is going to spark up.
Yeah.
It's, 10
Yeah.
Kind of spoil the party, but,
Yeah. I mean, like, okay, so you talked about the, I'll answer your own question too, but, you talked about, so like I talked about, right, you can do a lot more advanced analytics. So this talk was not just, it wasn't about the advanced analytics. It was just about getting in, because for me personally, I do advanced analytics. I do, big data stuff, AI and stuff, right? For me, the key thing is me being able to access the data. Once I'm able to access the data, just leave, I mean, yeah, and the advanced analytics will make this talk more than a 30-minute talk. So I tried as much as possible not to, include that, right? Then, I mean, talking about your own question, right? So what this can do for you when they say situational awareness, now they have what they call linemen that go about, they drive their trucks without no indication of, oh, this line seems like it's hot, right? If you can even reduce like, having like, instead of having like 20 crews go about aimlessly every day and, direct them, hey, okay, go to this pole, in Santa Monica. Obviously you have like a GPS sensor there, right? But if you can say, hey, okay, just go here. This is likely where it's coming up. I'm talking about advanced analytics. With that, you can even be able to predict ahead of time. Maybe you can say 1 hour time. I mean, I have my algorithm set up like within an hour. Tell me the likelihood of fire. That's going to save a lot of lives. I mean, save something, yeah. But
Question. I implemented this same sensor with an Arduino, but to get away from Arduino, I want to ask you about using CPython.
So you mean like Cython? Oh, yeah.
Yeah, where the hell we can ask it. Use that too?
So Micropython, right, under the hood uses, Cython. So, yeah,
Thank you.
yeah. But since you're in Python, since you're here, you like Python, so just go with Micropython.
So, very interesting. First, thanks really for sharing with us, and I hope that you're going to share your slide.
Yep, sure.
But my question is that embedded devices are notoriously weak in terms of, and vulnerable in terms of security.
Hmm.
Have you looked into security issues? What are the possibilities with this type of remote access and remote capability to create trouble?
I have. I think I want to say everything just depends on how much, people want to pay for it. So with this embedded devices, the great thing you can, implement what they call edge computing, edge computing. So now you could say, hey, I believe like within this hours of this time, there's not going to be anyone, eavesdropping. Let me push my data at this particular time, right? You can do that. But, locally there, local network, you're already like, talking back with your, smart, intelligent. But also another part for me, if you ask me, I also look at it beyond just the typical devices we have now. So there's what they call the RISC-V. I don't know if anyone knows about what they call the RISC-V, instruction set architecture. So it's almost like an open source architecture. So what that does for you is that you can take your security beyond the network layer, even down to the physical devices, right? Now you can even have algorithms that, because now mostly we're doing like network security, but now you can go down to the physical layer where you have those algorithms, making sure that the drivers, because you have like all drivers or sensors connected to it, they are not being like passed, spoofed like bad data sets. So for something like that, if you want to go another level, but in my opinion, even the current embedded devices integrated into these grid equipments, they are not that so sophisticated. I mean, in terms of the security they have, let alone when you integrate an edge device. So it's a question of what application, and what value do people see in it.
Thank you so much. Oh, sorry, one more.
Oh, sure.
So, quick question on transmission lines, right?
Mhm.
Very high structures where a good example you showed those insulators with a hook, right?
Yeah.
Do you have have you explored a way of installing those embedded devices to be able to monitor that? And then the other question is there a way that you can incorporate this so that when you see those things, you can easily trick the system?
Absolutely. You can do all of that. So what you just need is a sensor. So for something like that, right, you could have like a strain sensor, right? I mean, what you just need is literally like a sensor, right? Being interfaced with the embedded devices. You can be able to get that same data, the tension of the line, is the line sagging? You can be able to get all that. Then back to your question about the protection scheme. I mean, working with energy and power industry, the way they set what they call relays and breakers. So the way they set their relays and breakers are more static. It's just like I've already defined certain trip mechanisms. It's just like, when you're writing Python. So the difference between machine learning and, writing like static, routine code. If X is Y, shut this off, right? But with machine learning, you'll be like, okay, intelligently, when you see this, right? So the challenge is that within most utilities, right, they still use those, static ways of setting their relays and breakers. But if they can automate it, integrating intelligence to it, then that way, you can be able to, quickly trip the breakers or reset it, say, okay, you wanted to reset, and yeah, pretty much.
I think they have microprocessor relays that's able to do that now.
Exactly, they have that, but they should, the thing is, the folks that go implement it, right? Not a lot of them are, crazy people like me and you that wants to dig in, and do more, advanced stuff. So perhaps we need everyone here, right, to do some of that. Yeah.
I think we have a security talk in the works here.
I don't know.
Thank you very much, CJ. So if people have questions, can they talk to you during the break? Or?
Yeah, absolutely. And yeah, I'll share. Yeah, I'll be right here. Yeah. And you got my email. Feel free to shoot me an email if you would.